guys, Mr. Drew here again, and we're here to do another science lesson. Today we're going to review the atoms to get you ready for the big test. Let's take a look at the question of the day. What happens when sodium meets chlorine? Well, if I take a look at a sodium atom and a chlorine atom, I'll notice something special. The sodium atom has one electron on this outermost shell, whereas the chlorine atom is one electron short of having a complete 8 electrons in its outer shell. So the sodium will donate the electron to the chlorine, and we have here what's called a compound. This is when two atoms become chemically combined together in such a way that they create something brand new. And the way this is doing this is with the electron leaving the sodium, the atom becomes positive. The electrons going to the chlorine make the atom negative, and as you guys know, opposites attract. Our positive ions and our negative ions will basically stick together, forming a brand new material. We like to call that sodium chloride, also known as salt.
We've asked Lonnie to demonstrate the formation of an ionic bond. In this case, the bond between sodium and chlorine in sodium chloride. So Lonnie's filled a beaker with elemental chlorine. That's chlorine gas, Cl2. It's a yellow gas. They'll also use solid sodium metal. Solid sodium metal is a shiny silver metal that's very soft. You can actually cut it with a knife. Sodium metal is very reactive. It will react in air and water, so it's stored under hexane. He'll pull off a small chunk and immediately store it under hexane while he prepares the rest of the experiment. Now, to get the reaction to go, he'll want to clean the sodium, make the surface very clean, and warm it slightly to help the reaction proceed. He'll do that by placing the sodium in a spatula and then warming it over a flame to clean the surface and to get the sodium warm enough to initiate the chemical reaction. Now, the reaction between sodium metal and chlorine gas proceeds, but we know the ionization energy of sodium is greater than the energy release, the electron affinity, when chlorine accepts electrons. So the reaction goes because the positive ions formed on sodium and the negative ions formed on chlorine are drawn together, a Coulombic interaction, to form an ionic bond. The formation of that ionic bond, plus and minus charges attracted together, releases energy, and that's the driving force for this chemical reaction. And you can see that it's exothermic. Energy is being released. Bright red glow, typical of emissions from sodium. Now, the reaction between sodium and chlorine, of course, forms sodium chloride. We typically know that as table salt. And Lonnie's prepared some in advance. He has white table salt, purified, that he can show us. There it is, purified in advance from Lonnie Laboratories. And Lonnie tells me
Wow, so it looks like sodium and chlorine make a compound with brand new properties. I don't know about you, but I wouldn't want to eat pure sodium, the metal, because it reacts with the water in your mouth, the saliva, to form an explosion. And chlorine gas is a poisonous gas, which again I wouldn't want to try to eat. But putting them together, we get something brand new. Sodium chloride, also known as salt. All right, guys, let's take a quick look at what's coming up for you. The atom unit test. Thursday and Friday coming up this week. Your element project. If you want to build the model, that's totally optional, but don't forget the element project itself, due Wednesday. And just make sure you're keeping up with everything on Schoology. We did have hunting the elements due last Wednesday. Let's hope that all of those things are complete and you guys are keeping up. All right, let's just remember when we're on Schoology, anything that looks like this little pencil and this piece of paper back here with the blue, those are assignments. Those are graded. So make sure you're doing those things. If you click on your calendar, you'll often see anything that might be late. These are the things that are coming up. And please make sure that you are completing all of your Schoology assignments. Today we're going to review a little bit the atomic information, and we're going to look a little bit at your review packet. So if you do have your packet, whether it's on paper or electronic, let's take a look at the atoms and periodic table review packet. It's the last page of your packet. So let's review. Atoms are basically made of three smaller parts called protons, electrons, and neutrons. Atoms have a nucleus. The central part of the atom is made of the protons and the neutrons. That's where all the mass is. The atomic number is given to you by the protons. Remember, protons are positive, electrons are negative, and neutrons are neutral. They have no positive or negative properties. The mass of an atom is the protons plus the neutrons. We call those atomic mass units. We do not include the electrons because of their tiny mass. It doesn't actually make a difference in our atomic mass. The number of protons is the element. In other words, carbon has 6 protons. All elements with 6 protons would be carbon. But the arrangement of electrons determines a lot about the bonding and how it's going to interact and form compounds, as you just saw. The number of neutrons could determine an isotope of the element. Some elements could gain or lose neutrons, which changes the mass, and we call those isotopes. Alright, if I'm looking on my review for the periodic table, remember each box represents one element. Here's an example of how to read this. The number at the top, that's the atomic number. That's the number of protons, the positive particles. It also gives us the electrons. Because electrons are negative, to balance with the positive protons, number 1 in hydrogen means it has 1 proton and 1 electron. Our symbol is always a capital letter. If it has 2 letters, the second letter will be lowercase. Sometimes the names are or the symbols are given from names in different languages, so it might not match. In this case, hydrogen does match with the capital H, but for example, gold does not. Gold symbol is AU. Our name here, hydrogen, and our mass. Our mass here is the number of protons plus neutrons. In this case, it looks like the mass is 1.008. We're going to round this number because it's an average. Remember, there are some isotopes. In order to figure out the neutrons, we're going to take a rounded number of the mass. In this case, it would be 1. We're going to subtract the protons from that number and give us neutrons. Interestingly enough, hydrogen has no neutrons. Your job is to go ahead and fill out the rest of your review on the back. As you fill in, I'm going to let you do this and check back for the answers in our next video. But for example, you'll tell us the charge of these, whether it's positive, negative, or neutral. Its location, is it found in the nucleus, or could it be outside? And its mass being, is it 1 or no atomic mass units. Label your diagram. Where's the nucleus? Where are the electrons, protons, and neutrons in an atom? And for our final job for you, we're going to take examples of elements such as chlorine. You'll fill in the blanks. They give you the symbol Cl, the atomic number 17. I can find that from the periodic table, or I can look and see if they give me the number of protons. The number of protons is the atomic number, remember. It's also the number of electrons. That's why we have 17, 17, and 17. The mass, remember, that's a rounded number from the periodic table. In order to find the neutrons, we simply take the mass, subtract out the 17 protons. That leaves us with 18 neutrons. Let's do one more. Together we have oxygen, symbol O, atomic number is 8. That means that it has 8 protons and 8 electrons. The reason we have 8 neutrons is because we took the mass, 16, subtracted out the 8 protons, leaving us with 8 neutrons. So as you go down further, there's more and more blanks, which means you may need to use a periodic table to look up things like the atomic number or the mass. But from all of that, you should be able to complete this chart, and that will mean you'll be doing excellent on your test. To help you out, there are a couple of links in Schoology. There is a Quizlet, the atoms and periodic table for you. There's a little practice test there. There are flashcards you can look through. Quizlet is a really great resource as far as studying for tests and quizzes. Highly recommend it. There's also a link to a Kahoot where you can play along, and that's focusing mostly on the periodic table and being able to read the periodic table. I'll put in, with all the other video links, I'll put in the Bill Nye, and he talks about atoms, in a fun way. Of course, we all love Bill. And please look at the other video links to check out some of the resources that we've done. So, that being said, guys, thank you so much for tuning in. Hopefully you're going to do really well on your test on atoms, and those resources might help you. Check back next time for the answers for this review, and I hope to see you soon. Thanks for stopping by.